Hello everyone, welcome to this session. In this session, we will demonstrate the genetic algorithm optimization process by an example to let you understand it intuitively. So first, let's review the last session. How to use evolution to solve an optimization problem. So we call a solution in the search space is an individual in the natural evolution. So we do evolution to create better solutions. We start from a population of solutions, then we do the selection. After selection, we get the mating pool. Then by doing crossover and mutation, we exchange the individuals in the mating pool to generate new solutions. And for the last step, I replace the old solutions with the new ones. So this is the process, right? Now let's see how this process goes by a practical problem. So the problem as I prepared is here. So here we are going to maximize the function gx. So this is the expression of gx, right? So x is an integer from 0 to 15. So in the search space, there are 16 possibilities, right? So as you can see that what is the optimal value of this function? So 65 is minus something. So to maximize it, we want this item to be as small as possible. So when x equals to 8, this one is 0. So the maximum of the gx is 65, right? So the solution of this optimization problem is x equals to 8. Now we will see that if we follow the GA process, what will happen? First of all, we need to represent the candidate designs, right? So this representation should allow the crossover and mutation. So we choose the binary encoding. So we can see each individual can be represented by a binary string. So we can see here the x from 0 to 7, we have this binary code. And then from 8 to 15 is also there. So we can see from 0, 0, 0, 0 to 1, 1, 1, 1. These are from 0 to 15. And the optimum is here, 1, 0, 0, 0, right? So now we will see that if GA can generate this optimal solution or not, because GA doesn't know this solution beforehand. So here is the search space. Now we start the GA process. We have an initial population first. Let's randomly select 4 individuals to put in the initial population. Then we calculate what are their objective function values. So we can calculate this here. So remember the average fitness is 25.5. Right. So now then we will do what? When we initialize, we will do a selection. So selection based on what? The survival of the fittest. So the better solutions can have more chance to survive. So we can see the 1011, the 1011 has been selected for twice, and the worst one, 0000, was just eliminated. So mating pool with 4 individuals. Then the next step is to generate the new population by crossover and mutation. So let's first get randomly select 2 individuals. We randomly select a place to crossover. Then we do the crossover. We can see that 1000 are here, but this 11 comes here. This 10 comes here. So crossover. Then we randomly select a point to do mutation, either from change from 0 to 1 or 1 to 0. So here we can, after mutation, we get the 2 new solutions. So we put them into the new population. They are here. Now I do another process. So randomly select 2 individuals from the mating pool. Okay. Then we find a place. We do the crossover. Then we randomly find a place to do mutation. 0 change to 1. We generate another 2 candidates. So we put them to the new population. So now the new population is formed, right? The next step is to replace the old population. So let's see where are they. You can see it's here, 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 right? So then we will do the replacement. But before that, remember, in the current population, the best one is 56. That has an objective function value of 56, and the average fitness is 25.5. Then we see how the new population's objectives are. So we can replace it. Then we find these are the new population. We can find this is their objective function value, and we can see the average fitness improved a lot from 25 to 61, right? And we can also see the best one also improved with 64. Two of them are 64, right? Okay, with this current population, we start another selection, and we can see it here. Survival of the fittest. We can find the best one, 1, 0, 0, 1, selected by choice. And the worst one, 1, 0, 1, 1, removed, right? This is just an analogy, survival of the fittest. In real case, it may not be like this. Maybe another one selected by choice, right? So then we can randomly select two of them, find a place to crossover, and then we randomly select one place to do mutation. We generate two individuals, go to the new population. Then we do another selection. Okay, this time we select these two, and we randomly find a place to do crossover. This time we cross over here, and we see the exchange the last digit. Randomly find a place to change from 1 to 0. We generate another two solutions. So we can see a new population is generated. Let's see where are they. Here, 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 right? So remember the last population, the average is 61.25, best one is 64. Now let's replace it and see what the new population is now. This is the new population. We can find what? The best design, optimal design, 1000, already there. Gx is 65, right? So we already get the global optimum using 3 iterations of GA. Beforehand, GA doesn't know where is the optimal solution. So this is how GA works, right? So clever, right? So GA can continue to produce new generations of populations again until some stopping criterion that is met, which we will talk about in later sessions. So at last, we summarize the GA flow, right? GA we first do the initialization, then we do the selection based on survival of fittest, then we do the crossover, then we do the mutation, then we do the replacement. If the termination conditions are not met, we repeat this process until it's met. Then we get the optimal solution that GA can find. Right, so this is the workflow of GA. Okay, that's all for this session. Thank you very much. Bye-bye.